Hello, it's Keith here, and this is lesson 3 of the Arm Thumb series of my assembly programming tutorials, and today we're going to be discussing flags, conditions and branching on the Arm Thumb. Now, if you're familiar with Arm, I'm going to make this very quick for you. Basically, the Arm Thumb does not have the same ability as the Arm to specify which commands change the flag and which commands don't. The commands themselves will define which flags they change. If you want to check out which ones do and which ones don't, then you can have a look at my cheat sheet on my website. But alternatively, any book on Arm Thumb commands will describe which ones change the flags and which ones don't, which ones change which flags, because some change a few and not others. So basically, apart from that fact, all of the commands we use to work with the flags are the same. The branches are basically the same. We're going to be going over them again today, so if you need a bit of a recap, you're welcome to stick around and check them out. But if you just needed to know how the Arm Thumb had changed, that's basically it. You can no longer specify which commands change the flags and which don't. It's the commands themselves that do that now. Anyway, let's go over to the source code and let's check out what we're going to be doing today, and let's learn about these flags. Okay, so as always, we've got a variety of tests we're going to be running. The first one is just going to check out the flags, and then we've got a series of tests based on those conditions. So let's fire up our example here. Let's get it at the top here, and let's see our source code. Okay, so we're running this flags test, and what we're going to do first is we've got some test commands here, and these are just designed to clear the flags. Now, if you look over here, you can see we've got the flags shown as letters here. So when a flag is set, the letter will be shown, otherwise it will be shown as a minus here. And so we've set a starting value with R0 equal to all Fs, and we've got this from this no carry value down here. So we've cleared the carry by adding 1 to 1 here, which of course does not cause a carry. And then what we've done is we've loaded this value into R0. Now the LDR command does not change the flag, and we can check that if we just have a look at that cheat sheet. So here's my cheat sheet, and you can see here the LDR command does not change any flags. You can see this column here has which flags are changed by which command. So as I say, you really need to just check some kind of documentation to see which of the commands change the flags when you're working with them. But LDR does not change the flags. So when we've loaded that value in here, the flags have not been set accordingly. Now what we've done next is we've added 1 to R0, and that has caused R0 to go from all Fs to a 0 here, and that has caused a carry to occur. So you can see the C flag and the Z flag have now been set by that rollover. What we've done next is we've reloaded that value into R0, and the point we're making here is that although R0 has changed here, the 0 flag and the carry flag are still set, and the negative flag has not been set because LDR does not set the flags. However, the move command does indeed set the flags. So when we've moved that test value into R0 again, even though R0's value hasn't changed because we've effectively reloaded the same value in, this time the flags have been set accordingly. So the 0 flag has been cleared and the negative flag has been set because that move command set the flags, but that LDR command did not. And so the point I'm really making here is that some commands will change the flags and some commands will not. And you just need to check to see which ones do and don't when you're working with the flags to make sure the flags will be set as you expect by the previous commands. Okay, now we're going to do some tests based on the carry. So what are we going to do? Well, what we're going to do is we're going to load in a test value into R0, and then we're going to do some addition which will or won't cause a carry depending on the value we load in. So the first value we're loading in is all Fs, and that means that we are going to cause a carry when we add 1 to that value. So we're loading that test value in, we're adding 1, and you can see here when we've loaded that value in, the carry was clear, but then we added 1, rolling it over to 0, and that has caused the carry to be set. Now after that we've got a branch which is going to occur. BCS is branch if carry set, and we're going to jump to this carry command here, and branch if carry clear is going to jump to this no carry command. Now these are just little test labels that will show a letter to the screen, and so basically these are either going to show a C or an NC depending on if the branch occurs to the carry or the no carry. So really these are just confirming which of these branches actually occurred. So branch if carry set will occur if the carry is set, branch if carry clear will occur if carry clear is the case. And you can see here the C was shown, so the carry was set. As we can see from that C in the line above, the Z is also the 0 flag, which is also set. Now if we just change our code here, if we just run this line out here and instead enable this line here, loading the no carry value, and we run it again, well, now you can see we loaded in all F's and an E. We added 1, which rolled it up to all F's. Well, that set the negative flag, but it didn't set the carry flag. So this time the jump if no carry is set, branch if carry clear. So we've jumped to this label and we've shown an NC for no carry. So you can see how those branches are occurring based on the flag. So that's the carry flag. We're going to look next at the equals flag, and this is of course going to work based on if the result is 0. So here it is, if we just fire this up. So what we're going to do here is we're going to load R0 with a value, and we're going to load R1 with a value, and then we're going to use the compare command to compare the two. So we're going to compare R0 and R1. Well, in this case they're both the same, so the difference is negative. So when we do the comparison, the effect is setting the 0 flag. We're then going to branch if equals to the jump equals, which will show an equal sign, or the not equals will jump to the not equals routine. Well, of course those two are the same, so the 0 flag has been set and we've branched and shown the equal sign. Now the compare command is effectively like a subtract command, and it sets the flags accordingly, but it doesn't change the values. So that's what's happened there. Now if we change this and we change the value of R1, this time we're going to load in the value 11 into R1, which of course does not equal R0 now. So when we run again, well, this time rather than the branch if equals occurring, the branch if not equals will occur. The 0 flag is clear, and so we've branched and we've shown an exclamation mark equals, which is the not equals sign in C and things like that. So you can see we can branch depending on the equals. Okay, so this time we're going to try a different command. We're going to try compare negative. Now this is a bit of an odd command. Effectively this is the opposite of a compare command, and whereas a compare command does a subtract, the compare negative effectively does an add. So basically if we just run this with the two test values of 10 and 10 and we do a compare negative, well, a normal compare would have set the 0 flag and that would have caused a jump on branch if equals here. This branch would equals would have shown an equal sign. However, this time the 0 flag is clear, so we've shown a not equals. Of course the register values, while they're the same, haven't changed. The compare negative, just like compare, doesn't change the registers themselves. So this time we're going to use this neg command to negate the value in R1, and if we run again now, well, this time the value in R1 has been flipped there, so that's now a negative value, and when we effectively add that to R0, because that's what the compare negative command does, it is effectively an add command. Well, when we add those two together, well, now the 0 flag is set, so our branch if equals occurs, and we show the equal sign here. Now this value F6 here is effectively the equivalent of a minus 10. If I just get my calculator up here and we do a minus 10, well, you can see here that F6 is minus 10, and you can see that is the value that we've got here. Now the reason we've used this neg command is we can't load an immediate minus 10 in with this move command, so I've used that instead. So there we go, that's how the compare negative command can be used for the equivalent setting the flags like an add would have done. Now what we're going to do next is we're going to look at the greater than and less than comparisons, but these of course actually vary depending on if we're using signed numbers or unsigned numbers. So first of all, we're going to be comparing unsigned numbers. Okay, so what are we going to do? Well, first of all, we're going to load in some test values. We're going to load in R0 with 10. We're then going to load R1 with 5 here first, and this is going to effectively do a test of the greater than function. Now, in this case, we're comparing R0 and R1. Now, in this case, R0 is greater than R1, and so our branch is showing a greater than symbol. Now, in this case, we're using BHI and BLS. And these are branch if higher and branch if less than or same. So these are working with unsigned numbers and have branched accordingly. Now we do have some alternate ones. We can use branch if carry set and branch if carry clear. The description doesn't quite sound so clear, but basically branch if carry set will branch if greater than or equals, and carry clear will branch if less than. So the equals is in the opposite position there. We can just try those out as well. And so once again we've branch if greater than. These will only really make a difference if the two values are equal, and we can of course make them equal if we want. If we just put in a 10 here and we run it again. Well, here we've jumped to the greater than sign because branch if carry set will branch if greater than equals. But if we change this, if we rem these two out and we do branch if higher or branch if less than same instead, well, this time we've shown the less than symbol because the less than or same has occurred. So it just depends what we want to happen depending on whether the two values are the same, which ones of these we want to use. Now, those of course all work fine for values that are higher than or lower. The problem is going to come if we use a negative value. For example, let's load R1 with 0 here, and then let's subtract 20 from R1, effectively making R1 a negative number. Now, of course, in unsigned mathematics though, this would look like a very large number. You can see that is kind of a very large number, but if it's signed then it's a small number. So when we've compared the two, well, according to this, R0 is less than R1. So we've shown the less than symbol when actually R0 is greater than R1 because we meant it to be a signed number, and that's because we've used the wrong commands. So rather than those, we need to use different commands for the signed numbers, and we will see those just now. So here's our signed number commands. We're going to be using BGT and BLT, or BGE and BLE. Of course, we used BCS, BCC, BHI and BLS before. So these are the signed equivalents. And if we run this again, well, here you can see we've got R0 equals 10 and R1 equals 20. That 14 is 20 in hexadecimal. And we've done branch if greater than or branch if less than, and you can see R0 is less than R1, so we've shown the less than symbol. Now if we just change these, if we rem this line out and then we subtract 20 from R1, R1 will be 0 at that point, and we run this again, well, now R1 is a negative number, and so R0, being a positive number, is greater. So the branch if greater than has occurred. Now once again though, these will vary, the commands we will want to use will vary depending on how we want to respond if the two values are the same. So in this case, both of these will only respond if the value is greater than or less than. So in this case, where the two are the same, we've actually skipped through to this no jump command, which has just shown a dot on the screen. Now if we used our alternate commands, branch if greater than equals or branch if less than or equals, then these jumps would occur, and in this case we're running both consecutively, so it's simply going to depend which one came first, which is going to actually end up occurring. So we've ended up jumping and showing the greater than symbol there. So there we go, we've got different commands depending on if we're working with signed or unsigned numbers, which is pretty typical really. What we're going to look at next is how we can test the sign of a register. So here what we're going to do is we are going to load our register with a positive number here. We're loading R0 with a positive number, and we're using BPL for branch if plus or BMI for branch if minus. Of course the value is positive, you can see that, and here we've got no flags set, so we've branched if positive and shown a plus. Alternatively, if we change this and we do a subtraction here. So this time we're subtracting R1 from R0 here. Well, that's going to set R0 to a negative number there. The top bit is a 1 there. So our end flag has been set, and our branch if minus has occurred, and we've shown a minus sign to the screen to show that. So that's how we can do branches on positive and negative. Now the other one we're going to discuss is the overflow. Now this is designed to be used with mathematics when there's a possibility that our command could cause the sign bit to accidentally flip. Of course, if we subtract 1 from 0, then the sign will change from positive to negative, but that's not an accident. The problem that will occur is if we've got the absolute limit of the sign numbers and then we add or subtract 1, causing the top bit to change, which will effectively unintentionally flip the sign, and this is what's referred to as overflow. So we've got a test here. We've got a value we're loading into R0, which will cause an overflow when we add 1 to it. And so let's just fire this up here. So what we've done here is we've loaded our test value into R0. We've then added 1 and stored the result in R1. So you can see R0 here had a value of 7 and then a lot of F's. The top bit was of course 0, so that's a positive number. But when we've added 1, the top bit has changed to a 1, so that is now unintentionally a negative number. And so the overflow V flag has been set, and our branch if overflow set BVS has branched, and we've shown a V to the screen to show the overflow has occurred. Now if we just change this and we load our alternate value, which will not cause an overflow, we're loading in this time 7, lots of F's and then an E. Well, we can add 1 to that without the top bit changing, so the overflow flag is clear, and we've shown NV for no overflow, and that's because branch if overflow clear occurred. Now in that case we showed it occurring when we went from a positive to a negative number, but the exact same thing will happen whether we go from negative to positive or positive to negative. It's any time that the sign unintentionally changed because of the previous mathematical command. And there we go. So that's all we're going to be covering today. You can of course get the source code for these, and I would encourage you to do so, because the best way to get hang of the flags and the conditions is to try using a different set of variables yourself and just see how the various commands occur. And of course you can see the flags on screen with the little test code. As always, if you like what we've seen, please like and subscribe. And as I've mentioned before, I do have a book available on Amazon. It doesn't cover ARM Thumb, but it does cover Classic ARM as well as Z80, 6502, 68000 and 8086. It's called Learn Multi-Platform Assembly with Chibi Akamas. You can get it from Amazon now as print or digital. So please do that if you want to support my channel. Anyway, I hope you've enjoyed this. Thanks for watching today, and goodbye.